my name is Ken Johnson. I'm with Mitsubishi Electric. I've worked for Mitsubishi for a little over 4 years, and most of that time was in the solar division. I recently joined the performance construction team in April, and so I'm not an expert on HVAC equipment. I'm still learning, but I'm working with new home builders, trying to convince them to move from traditional HVAC systems to mini splits, which are much more efficient. And as Sean mentioned, I did live in Japan for 6 years. I worked for an organization called the New Energy Development Organization. It's a governmental agency under METI, the Ministry of Economy, Trade and Industry, and they funded renewable and energy efficiency research and development. So I wasn't a student there, actually. I was the English expert helping with communications, but it was a really good experience. My wife is Japanese. We had a young son at that time. He's 21 now. And we ended up building a house in Japan, which is an interesting experience too. So, oh yeah, no problem.
Thanks for riffing.
Yep. No problem. And I think before we start, since this is a sanctuary, we should pray for a good presentation and one that comes in on time, right? Okay.
Well, when Amory Lovins starts, I'm going to try to start him on time. When Amory Lovins is doing these speeches, I would like for people to sign up. I'd like specifically, I'm just going to say, I'd like for the women to have an opportunity to ask the questions first, like the first 2 to 3 questions. Generally, in every single session, it's been the first 3 questions have been men that have asked the questions. If you guys didn't notice, I totally pay attention to that stuff. So I'm going to ask you to recalibrate who goes first. Take turns, all of us. It is, I tried to make it 50-50 male-female crowd. It didn't end up working out that way. I tried hard. We had some cancellations and extra guys showed up.
You'll need us next year.
Absolutely. We're all the same page. And just to know, we are doing a generational change. I mean, like the baby boomer was a thing, and the money boomer is a thing. And I think that as we do generational handovers, which is just natural, you know, I'm 40 and I'm doing handovers, and I know when I'm 60 and doing handovers, but this is the nature of generational change. So I encourage you, when you are participating in this process, to recruit and to make the next society better than the one that we inherited. You know, in all senses of that word, of course, but that's something to think about actively, I think, in our own context.
There we go. Thank you for riffing. So in my presentation today, I'm going to start by talking about mini splits, which are also known as air source heat pumps, talk a little bit about what we're doing in the US, and then talk about Japan. We have a unique product over there that Sean was pretty interested in, so I'll tell you about that. And if time, and some other things that are happening in Japan, a little bit of what we're doing in Europe, and then if we have time, I'll talk a little bit about a smart house, but we may run out of time before then. So, are we good?
Yes.
All right.
I was ready to think that bar will be here in front of you guys this whole time. Oh, I apologize.
Okay. No problem. Can you guys see okay from the back, or is it okay? You can always see it on your laptops too if it's too far away. All right. Okay, great, thank you. Looks like it cuts a little bit off the top too. There we go. A little bit lower. There we go, thank you. All right, so mini splits, again, air source heat pumps. They've been adopted worldwide in really big numbers. In Japan, it's about 89, 90%, Asia, 84. Europe, very common. If you've traveled abroad, you've seen these everywhere, 73%, Latin America, 67. The US and Canada, 8% only. I don't know, I don't have numbers on those. I think Australia is probably high. Pardon me?
Percent of what?
Adoption of mini split technology
Versus what?
versus traditional traditional furnaces. So there are probably a few reasons. I mean, we don't change quickly in the U.S. and other places, I guess, too. But we've traditionally built ducted systems, and And I think like HVAC people are more comfortable doing what they know how to do. So it's been a little bit slower to adopt here, but it is growing pretty rapidly. This number was 4% not too long ago. And so 8% is a big jump. But we also know it's growing rapidly because the major manufacturers of unitary equipment are partnering with various mini split companies. We just announced a joint venture with Trane, for example. They'll be selling our equipment too.
When you say mini split, do you mean a ductless system or do you mean a variable compressor? What makes a mini split?
Yep. So I'll get into that a little bit more because we have both types, ducted and ductless.
But when you say 8%, I'm not clear. We have split heat pumps all over the US. What makes it a mini split?
Mini splits are smaller outdoor units. It's not generally the whole house. It's generally going to be a segmented, zoned solution versus maybe one big system that is powering the whole house, heating or cooling the whole house. Okay, next slide, please. So what are the advantages of mini splits and why have they been adopted so much in other parts of the world? They're very quiet. When they're running, oftentimes you wouldn't even know it. We call it whisper technology because it is at the decibel level of whispering. Zone comfort solutions. So with a traditional system, you'd have one furnace that's going to heat the whole house at the same temperature. And you'd end up getting hot and cold spots. With zone comfort, you can have different units in different parts of the house and have rooms at different temperatures. And I'll have a slide on that. Better indoor air quality. You have multiple points of filtration. So it's a good way to circulate the air and get it filtered through multiple times. Efficiency levels are much higher. Generally, we say about 40% improvement in efficiency. They are all electric, which plays nicely into where we're going here, hopefully, with electrification of everything. And as the grid gets cleaner and cleaner, these become much more attractive. And as we do more and more solar, as what will be required in 2020 in California, this plays very well with that. And then space savings. We don't need all that ductwork space that, depending on which unit you use from mini split technology, but a lot of them you don't need any ductwork. So you can eliminate the vertical and horizontal chases. You can eliminate the air handling closet. So that could be a big savings, especially when costs of housing are so expensive on a per square footage basis. If you can free up space, that's a great thing. Longevity, our units generally are designed to last 20 plus years, whereas a traditional system, you're looking at about a dozen years. They're also very reliable. Our warranty claim rate is 0.88%, and the normal for furnaces is about 6 to 7%. And then variable sizes. As houses get built tighter and tighter, like let's say passive homes or even other homes that are just getting tighter, where the air changes per hour are really much lower than they used to be, having a big central system that might be 3-4 tons is really overkill. And with ours, you can get down as low as a half a ton unit. And we've seen some passive homes, 2,200 square feet, okay, that are being run, a 2,200 square foot house being run on 1 ton. The old rule of thumb was 1 ton for about 400 to 500 square feet. So you can see where this is going as we get tighter and tighter.
Just unmuting.
Okay.
For Zoom folks.
Oh, all right, thank you. Could we go to the next slide, please? Oh, sorry, this one didn't, but that one did. All right, so when I talk about zone comfort, this is what we're talking about. The analogy we oftentimes give is when you come home from work, you unlock the come in on the switch and turn on every light in your house. But when you turn on your air conditioning or heating, you are generally turning on the whole house. And with a zone comfort solution, you could turn on just the spaces you're in, and that saves a lot of energy as well. You can even have rooms turned off. If you're like my wife and I, sometimes one person likes the room warmer than the other, and so you can have comfort that fits more than one person. Next slide. Okay, Sean was talking a little bit about COP, coefficient of performance. I just threw this slide in here real quickly, but what we're talking about here is if you put 1 unit of energy into a system, how much are you getting out? In this example, it says 1 kilowatt of power coming into a heat pump and 4 kilowatts of energy coming out. So that would be a coefficient of performance of 4. A more traditional electric system, non-mini split, would probably have a coefficient of 1. So you can see the efficiency differences are pretty significant. We're looking at 2.7 roughly to 4.8 in the equipment we're selling in the US. We do have one in Japan. I found out, I got an email this morning, I think it's 5.22, and it's running under running on R32 refrigerant versus R410A. And we haven't brought that to the US. It's possible we could, but the unit is actually much bigger. So they think that aesthetically it may not be well received here right now.
The Daikin, we got specs from them, and they had a mini split clip normal. That was using R32 that had a COP, and we understand that not exactly clear if their COP is the exact same testing regimen as our COP, but within that context, it was 5.8.
Okay, yeah, that's very high. And I think they're one of the leaders in R32, so that could be part of it.
That's their stuff, actually.
Yep. Next, please.
What is R32?
It's a refrigerant.
I mean, what chemically, what is it?
Sorry, I don't know. Sean, do you know?
That's a long name.
Yeah, it's supposed to be better in terms of GHGs. So what another point I wanted to make is, what makes these efficient is that we use inverter technology, and we have a very soft start. I don't know if you have if any of you have traditional systems that when your air conditioning kicks in, you hear a loud boom. I have one of those. It's right outside my bedroom window. It's not great in the middle of the night. When ours start, they're very quiet, generally running about 3 amps only. So we call it the soft start. Then they ramp up, they hit the set point, and then they modulate around it, almost like a car on cruise control. Versus a traditional system, if we looked at that, it would be fully on, 100%, off. Hits a set point, turns off. Waits for the temperature to drift, turns back on full speed. So think of it like a Prius versus somebody pedal to the metal and screeching on the brakes every time. Big difference there. Next, please. One of our units, this is the FH series, is kind of interesting because it has a sensor built into it up there. And what that does is it scans the room. It does a thermographic image and it kind of divides the room into, I think, 732 blocks. And it says, this part of the room is hot and this part of the room is cold, and it tries to homogenize the temperature. So in this example, you see 2 people sitting here. This person's sitting by a glass window. It's quite hot. So the vanes in this unit are going to point the cool air over to him and cool off that part of the room. It can also tell if humans are present in the room. And if they're not, in 15 minutes, it will adjust the temperature up or down to save energy. And it can tell the difference between rover and humans. So it won't react to pets. Next. So the units, if you're not familiar with mini splits, this is what some of the designs are. The top one is called a wall hung. This is the most common one. If you've traveled or even here, you've probably seen these. When I'm calling a new home builder, sometimes they say, I don't want to see those things on the wall. They're afraid buyers won't like the look of these. So we have come up with alternative designs as well. A floor mount unit, ceiling cassette. This is brand new. It just came out in April, extremely popular. I'll show you an image of it later because I think it looks very good and people will accept that. This unit is actually ducted, this one and that one. This one could go above a ceiling and have a short duct runs hitting 2 or 3 rooms, like let's say a master bedroom, closet, and bathroom. Yes?
Is there some physical reason you couldn't build the wall with a cavity for that and inset it so that it was flush to the wall, face the wall?
Which one? No, this one?
Any of them. There's some physical reason you couldn't do that. They have to have flow around them a certain way.
Yeah, they do have return requirements. So yeah, the return, for example, on this unit is on the top, so you couldn't put it flush. You wouldn't get any airflow.
I think can you put it in the soffit? Is there a way to put it in the soffit?
I don't know. This one has to be horizontal, I know. It can't be vertical. I'm not sure.
I've seen plenty of applications where there are built-ins, like cabinetry around them.
Yes.
So, it can be tight up to it, but there's
Right.
a way to
There's
really recess it.
yeah.
Actually.
Yeah, there are design criteria, so you have to have X number of inches around to get the proper flow. And we've seen them done in a lot of different ways. We've even seen these wrapped, like you might wrap a truck. They've had it wrapped with the color of the wall or a woodwork if it's in a bookshelf, things like that to try to make it fit in a little bit better. This is more of a traditional system. It's still mini split and still all electric, but this could go in new construction to do the main part of the house or the entire house, or it could be retro. For example, I have an older house, so this would be a perfect fit for replacing my gas furnace with a mini split and still using the existing ductwork. Next, please. So this is an example of that one-way cassette that, you know, how it would look in a house. And tell me if I'm wrong, but this looks pretty good, I think. I don't think too many people would walk in and say, oh, I don't like that thing up there. Next, please. And the way these work is you have an outdoor compressor, and then you can have one or more indoor units. Our largest one can handle up to 8 indoor units, and you can mix and match different types. Or you can do a one-to-one. Let's say you have a bonus room or a garage you wanted to heat or cool. If you do a one-to-one, that's very efficient and can get SEER ratings of up to 33, which is extremely high. To put that in context, the normal furnace is about 14 that's getting installed today. The minimum requirement is 14. Sometimes you see 16, but you'd never see SEERs like this from a traditional system. Next, please. All right, so switching gears now, this is a presentation from Japan, and you'll see the difference in Japanese presentations versus American presentations, stylized. But this is called a product called Smart V2H, Vehicle to Home. Amanda?
I had a question from
Sure.
online asking, does Mitsubishi make a drop-in replacement for a gas wall heater yet?
No, not for a gas wall heater.
Can you repeat the question?
Does Mitsubishi make a replacement for a gas wall heater, right?
Yeah.
No, we do not. Yes.
Does former main space be used in commercial, like classroom, office?
Yes. Yep. And what I'm showing is primarily residential, but there are commercial equivalents of all of these. Yeah. Good question. Okay, so let's go to the next slide, and I'll tell you about this device, which I think is kind of interesting. Sorry, Amanda. Next slide. There we go. Thank you. So the idea behind this vehicle to home is that you could potentially use your electric vehicle as a battery system. And I think that's attractive to a lot of people. One thing we have to keep in mind here is Japan is different than the US, because in Japan, when you go to work, you don't drive your car. You take the train or you take the bus. So your car is at home. And that has a different dynamic than if you're driving your car to work. You can't really do some of the things we're going to talk about here. So anyway, the idea here is you'd have a solar system on your house. You'd have storage, and it could be the electric vehicle or it could be a battery storage system. And then you'd have energy efficient appliances. And then this HEM stands for Home Energy Management System, kind of the brains that makes all of this work. Next slide. Okay, so there are three ways that you could use this. The first idea is to support self-sufficiency. And if we're talking about grid harmonization, this is where you'd like this point of it, where you charge from your solar system to your car during the day, obviously. And then you discharge from your electric vehicle to the house at night. And then you're not really using much power from the grid. Okay, so that's great, right, for grid harmonization. This one, if you like grid harmonization, you wouldn't like so much. But from an economic perspective in Japan, this is the one that makes the most sense, because Japan has a feed-in tariff program. And when it first started, it was extremely lucrative, like the equivalent of about 47 cents per kilowatt hour for exporting. And when that came out, they got all these applications for about 65 or 85 gigawatts of solar projects. Not all of them got built, but anyway, so with this one, you would charge your car at night with time of use rates being really low, and then you would discharge it from the electric vehicle to run your house during the day, thereby maximizing how much power you can export to the grid. And the key point here is that you cannot export from your car or battery system to the grid. That's a regulation. If you could, that would have changed everything, but you're not allowed to do that in Japan. So this reduces the cost of higher electricity and really lets you sell at a higher rate. So that's an advantage economically. But it's also great because it functions as an emergency backup. So if you have a blackout, Japan's very prone to earthquakes and typhoons. If you had a blackout, you could run your house on your car. Now, a typical energy storage system in the US is 6 to 10 kilowatt hours. A car is oftentimes 30 to 60. I have a Volkswagen e-Golf, it's 38 kilowatt hours. That could run your house for several days and your whole house. With some systems like an inverter from SMA called the Sunny Boy, you get a couple of outlets that you could use the solar power from even if the grid was down, but you'd charge your phone and do a couple little things, radio, maybe a TV, not your refrigerator. But with this, you could do your whole house. So it's a big advantage. And you don't need special outlets. I was in Japan and saw this demonstrated at the Smart House. It takes a few seconds to kick over, but it's, you know, you'd be happy to have it if you were in a blackout situation. Next, please.
And when's that coming here?
I don't know if it will. To be honest, it has not sold well in Japan.
Up to the PhD.
Yeah, I think in Japan it's a perfect market for electric vehicles, but they haven't really been adopted in big numbers yet. And I say it's perfect because people don't drive much at all. I knew a lady in Japan who had a car for 10 years and she put 4,000 miles on it. Because you're just using public transportation all the time. Yeah, I know, I wanted to buy it too. Excuse me. So, so advantages, I kind of talked about this a little bit, but you have a lot more battery storage with the car than with your house, than with a storage system. The amount of power you can draw is 6 kilowatts, which is, I don't honestly know, like the Tesla Powerwalls, how much you can draw at one time, but 6 kilowatts is quite a bit. And you don't have to tell it which appliances to power. It can be the whole house. And it's saying here that it charges twice as fast. I think what they're referring to here is, if you're familiar with the electric cars, there's level 1, 2, and 3 charging. With this one, you get level 2, which is what, if you know, that's kind of the 5.5-hour charge versus, you know, 10 to 20-hour charge with a normal 110 outlet. Next, please. Okay, I won't spend too much time here, but what they're trying to emphasize is that you have multiple choices for drawing your power. It could be from the EV system, it could be from the PV, or it could be from the grid. So that flexibility is kind of nice, because in the US, if the grid goes down, you can't use the power from your solar system. And a lot of people don't realize that. They think that, hey, power goes out, I've got my solar system still. Unless you have a special inverter, you really don't. Next. Okay, so this is just an illustration of how that would work in terms of using the EV and maximizing your exporting to the grid. Most of this is in Japanese, but this is charging the car at night when the rates are low. Okay, now you wake up in the morning, sun's not shining yet. You start drawing power from the EV, from the electric vehicle. The electric vehicles essentially going to power you all day. And here's your solar production. And instead of, you didn't think I'd have to step up here, did you? Instead of, you know, using this much solar power to power your house, you can now take all of that solar power and export it to the grid. So economically, that's a great way to go. Next, please. Okay, so net zero in Japan, the homes have to be 20% more efficient than an ordinary home, and I don't have the details on this. I don't know what their ACHs are, or their R20, or their R requirements for insulation. They have to be more airtight so that the efficiency of the air conditioners and water heaters is improved.
I'm sorry, before we move on to the next thing, I'm just curious about the price of that unit, if you happen to know.
I don't, but I can find out easily. Yep. Yep.
Going back to the EV home, Sean knows I've kind of been looking into this as well, but one of the things I've run into is auto manufacturers not wanting the power to be.
Yes. Yep, I've read that as well. Yeah.
If there are certain vehicles that are on board with that over in Japan?
I don't know what their position is there, but I know that is a concern with auto manufacturers. I don't think they've limited it in their warranties yet. At least I haven't seen anything. But what they're afraid of is just more cycling and wearing out the batteries sooner.
As far as the technology goes, do you know if the car batteries will allow that to flow back?
Yeah,
This device?
they will. Yeah, I don't know how many have been tested in Japan. They do mention the Nissan Leaf and the Mitsubishi Miev as options, but I'm sure. I would think most cars it would work. It'll probably depend a little bit on the interface for charging. So I'm not sure about the Tesla, for example. That's a little bit different. Okay. Efficient ventilation and then solar power that's going to offset the building's consumption. So nothing too surprising here. Japan is building, I think the target is to build about 50,000 zero net energy homes by 2020. And Japan's really different in terms of the building market. You won't see like massive new developments that are common here in California or other parts of the country. What you'll find is homes were built in the past to last 25 years, which is surprising, right? And then they would knock them down and build a new one. and repeat. Now they're being built better and better. Like the house we built would last about 75 years. So that's more reasonable. And it seems kind of like a waste of resources to do that. But after the war, I think they kind of got in the mentality of just build quickly. There was very little insulation, drafty homes. So anyway, I've got 5 minutes. So I'm going to step it up a little bit. So let's go to the next slide. So in terms of vehicles, Japan just announced this week, actually, that all passenger cars are going to be hybrid or electric by 2050. That may sound good, but in my opinion, that's not great. I think Norway already said 2030 they would do it. So this is pretty conservative. Japan has led the way in hybrid technology, as I'm sure you know, with the Prius and other cars. They're also doing hydrogen fuel cells. I don't know if you've seen the Toyota Mirai. Honda also has a vehicle. The Nissan Leaf has been a global leader, obviously, for electric vehicles, and now the range has been extended and they look much more stylish. So hopefully Japan can beat this, but that's what their target is. So let's go to the next slide. In Europe, sorry, this is still Japan, EcoCute, kind of a funny name. When I was in Japan working there, this came up. I'm like, oh no, this is a bad name. And it's not Mitsubishi's name. It was a consortium of companies funded by the group that I was with, Netto. And they developed this heat pump hot water heating system. And so a lot of different companies make an EcoCute system. Japan likes cute. And one of the things about it is it's good for residential, domestic, industrial, and commercial. And it uses supercritical carbon dioxide, which is a more GHG-friendly gas. Next slide. Yes.
How is supercritical carbon dioxide different from carbon dioxide?
I was afraid you were going to ask. I tried to go quickly.
Really important. We'll talk about the physics of it a little bit.
I do have something technical I could email you on that. Oh, okay, good.
I'm a little later.
Okay.
But basically what happens is that at very high pressure, the carbon dioxide becomes something that's not a liquid and not a gas, and certain properties that are valuable exist under these very high pressure conditions.
Okay, thank you, Michael.
So the EcoCute is a split air to water.
Yes, exactly. Yep, yep. This unit is called Ecodan, and we do make this and sell it in Europe. And it's used for two purposes, which is great. It heats and cools homes and uses the radiator systems that are common in England still. And then it can heat the domestic hot water, and it's tankless. So that's nice. Next slide.
You said tankless.
Tankless, yeah. Yeah. And then there's a combination you could do with Mr. Slim, which is kind of what our mini splits here are known as, and an Ecodan combination, where you don't have to, you could do the in-floor heating, but you could also do ducted heating and hot water. Unfortunately, this got, oh, there it is. It has a COP of 7.0, so extremely efficient. Let's go to the next slide. I'm not sure if this one, this is the smart home. How much time do I have left?
There's a couple minutes.
I'll go real quickly through this. So we have a couple of smart homes in Japan. I've taken customers there to tour them. They're pretty nice homes. I mean, everyone that goes in says, I'd love to live here. Let's go to the next slide. One's in Kyoto, one's in closer to Tokyo in Ofuna. They've been around for a few years now. Next slide. And they're PV powered. They do have storage. They do have these vehicle-to-home chargers and dischargers, and they're very efficient. And I think I'll go ahead to the next slide and possibly, okay, so the insulation is 2 times better than normal and more airtight compared to a traditional home. Next. And run again by a home energy monitoring system called HEMS. Let's go to the next slide. And I wanted to get to this. So these are some of the appliances that can be supported by this home energy management system. So room air conditioning, more of a whole house type of air conditioning system, heat pump hot water, induction IH cooking stove, exhaust fans. All of these systems can be controlled by the home energy management system, and they can be controlled from your tablet or your smartphone. So you could adjust all of these things while you're out of the house even. Even the refrigerator, your TV could be turned on and off, ERV systems. So it's pretty neat. There's a lot more to this. If we had more time, I'd tell you more. But like when you grab the door handle, for example, it will recognize you and know things about how you're doing, your physical state and things like that. So a lot of advances being made in that area.
Send a diagnosis to my doctor.
Yeah, maybe. Anyway, thank you. I know I really rushed here. Are there any last second questions? If not, I'll turn it over to the next speaker.
All right.
Thank you. Thank you.